So moving on, the food molecule or that have been mixed with the digestive enzymes and HCl will be passed to the small intestine. So the small intestine is the longest section of the alimentary canal. So the part of the name small comes from the diameter relative to the diameter of the large intestine, but it doesn't indicate the length. So actually the length of the small intestine in human is about 6 meters. So it is actually longer than any one of us. So small means referring to the diameter and not the length. So this is the major organ for digestion and absorption. So the small intestine is the major organ. Within the small intestine, the pancreas produces an alkaline solution to neutralize the acidic chyme. So if you remember, the food is reaching the small intestine from the stomach. Within the stomach, it has been mixed with the acid. Now we have a chyme which is highly acidic. If it is allowed to pass through to the small intestine, this will damage the lining of the small intestine. That's why we have to neutralize this acidity by alkaline solutions being secreted by the pancreas. Why? Because now we don't need this acidity anymore. The acidity has done its part and now we don't need it. So we have to protect the small intestine from this acidity by neutralizing it with alkaline solution. In addition to that, the small intestine includes a bile. So bile are secretions made in the liver and stored in the gallbladder. So they will be secreted from the gallbladder and they will help in the digestion and absorption of, as you can see, fats in specific. So this will be shown in the next slide. So in the next slide is a very good summary of the digestion of the different 4 types of macromolecules. So in the y-axis, we are going down through the alimentary canal, starting with the oral cavity, pharynx, and esophagus, what will be digested there, and what is happening there, then what is happening in the stomach and in the small intestine. So starting with the first type of the large macromolecule, it will be carbohydrate. So if we consume polysaccharides or disaccharides, what will happen within the oral cavity is that we have salivary amylases. They will act on the polysaccharides, breaking them down into smaller polysaccharides or into disaccharides. Disaccharides are already small enough, so the salivary amylase will not act on the disaccharides. They will pass the oral cavity, and these smaller polysaccharides also will pass the oral cavity to the stomach. Within the stomach, nothing will act on the stomach. Remember, the stomach secretes the HCl and pepsin. I will come to this later on, but now let's focus on the stomach. So it digests proteins. So carbohydrates are not proteins. That's why no digestion will happen in the stomach. They will pass to the small intestine, and within the small intestine, additional amylases secreted by the pancreas will digest the polysaccharides into smaller fragments, and at the end we will get the monosaccharides. So don't worry about the name of the enzymes and from where they come, just focus on the end result. So at the end we'll get these monosaccharides which will be absorbed. So starch digestion happens starting in the oral cavity, then the next step will be in the intestine, and the final product will be the monosaccharides. Moving on to proteins, so nothing will happen in the oral cavity. So the amylase does not digest protein. So the main digestion, the first step of digestion will happen in the stomach by the action of the HCl and the pepsin. And what I wanted to say, even the name pepsin comes from the fact it breaks down peptide bonds. And as you know, peptide bonds are the bonds connecting the amino acids of the protein. So protein's digestion will happen in the stomach with the aid of pepsin. Then these small polypeptides resulting from this digestion will be passed to the small intestine, within the small intestine we have additional peptidases. So let's just call them peptidases without going into details. So we will have different peptidases which will continue the digestion till we finally get the amino acids, the end result. Moving on, the digestion of nucleic acid. This will start in the small intestine by the action of nucleases. So again, just let's call them nucleases. So by the action of nucleases, we will get at the end the nitrogenous bases, the sugars and the phosphates, the end products. Moving on to fats. So the digestion of fats will happen in the small intestine by the action of the pancreatic lipases. This will digest them into their components, glycerol, fatty acids, and monoglycerides. So this summarizes the whole process, and it shows you the main organs involved in the digestion of the 4 types of the macromolecules.